a GPS device, a helmet camera, a driver, and on the passenger seat, a Swiss television cameraman. They demonstrate how poster contacts occur and are measured in practice. We are cruising on a typical suburban route near the city of Winterthur. The helmet camera captures what the passenger sees. Current insights in brain research tell us that visual perception works as follows. Generally, at high speeds, objects by the roadside are perceived only in sketchy outlines. When a certain object arouses interest, the eye focuses on it and briefly tracks it. This evokes something like a snapshot that lingers on in the mind for fractions of a second. Poster contacts are based on the same principle. On a digital map, the route of the cameraman is recorded in real time. The GPS unit determines his position at 1-second intervals. When the visibility area of poster panels is traversed, the system calculates the speed, the angle, and the time of the passage. The passages are then weighted to yield poster contacts. Here, the test vehicle passed the poster panel frontally at 68 km per hour and at a passage angle of 1 degree. Such a passage counts as one contact. The weighting for such frontal panels is 1 passage equals 1 poster contact. The cruise continues. The eye focuses on traffic signs by the roadside. Let's briefly analyze the brain's perceptive capacity. This traffic sign contains 10 items of information that are perceived within a minimal time span. They help the driver make correct decisions and react appropriately. We are approaching a roundabout and frontally pass 2 posters displayed at the bus stops. In the industrial district, we pass a pair of panels that are parallel to the road and located on the left side. Here we can see the route as recorded by the GPS unit. The frontal passage of the poster sites at the bus stop shelters is followed by the parallel passage through the visibility areas of the 2 poster panels on the left side of the road. Such parallel passages are weighted with 2 factors. Because the speed was greater than 10 km per hour, the parallel passage is diminished by a factor of 0.3. And because 2 panels were clustered, the contact rating is diminished by another 0.8. This yields the following calculation. 1 passage times 0.8 times 0.3 equals 0.24 poster contacts per panel. Every country has its own poster heritage. SPR research was designed explicitly for Switzerland because of the special aspects that we can easily see along this route. In contrast with the predominance of large billboards in other countries, the Swiss landscape is dominated by F200 and F12 poster formats. They are optimally suited for the more compact traffic environments of our country. With their high density, they can provide a poster presence that extends straight into the urban centers. We are passing the sites at a speed of nearly 50 km per hour, and therefore our perception of the posters displayed here on the right side of the road is only brief and fleeting. The route analysis concurs with our subjective visual impression. The parallel passages are again down-weighted by a factor of 0.24, while frontal passages count as full contacts. Here we have a new situation. 3 posters at a single site. The clustering of 3 posters leads to an even tougher rating. Each single panel is weighted only with a factor of 0.65 because it has 2 adjacent panels. And here again, a downweighting factor of 0.3 is applied for parallel passages at more than 10 km per hour. The resulting calculation is 1 passage times 0.65 times 0.3 is equivalent to 0.2 poster contacts per panel. Let's summarize. On this test route, we have seen the posters of 11 customers on a total of 27 panels. Taking Vögele as a model customer, the following picture results. 5 passages generated 3.48 poster contacts. With pedestrians, the pace is less hurried. Because passers-by have more time to turn their heads toward a poster, parallel passages of standalone posters generate 1 full poster contact. The same goes, of course, for frontal passages involving single posters. The case is different when several poster panels are clustered at a single site, like here at this tram stop. Even though the pedestrian has more time to look at a poster than the car passenger, the clustering of posters consistently entails a downweighting. This is also reflected by the evaluation of the pedestrian's GPS data. The parallel passage of the single poster was recorded as 1 poster contact. At the dual poster site, the passage was downweighted by the factor of 0.8 due to poster clustering.